Hi everyone, myself Dinesh, Assistant Professor, Department of Mechanical Engineering from SNS College of Technology. Okay. In our previous videos, we have seen the economic analysis of solar energy utilization. Okay. So there we have seen the mind map and the four elements which are very much important, like payback period and the overall the installation cost and everything. So here we are going to see the present worth calculation. Okay, the present worth calculation in the terms of payment of loan is in equal annual installments. Okay, so this is also a design thinking approach to solar energy based on financial. Okay, so this module of financial mechanic of solar energy utilization, we will expose how to calculate the present worth of future loan payment and critical skill for sustainable engineering investment. Okay, so this is the financial ecosystem in the terms of mind mapping. So first let's see the time value of money. Okay, the principle that money available now is worth more than the same amount in the future. Okay, that's what we call it as the time value of money, and which is followed by EAI, which is equal annual installments. Okay, a series of uniform payments made at the end of each period, which is what we call it as a EAI. Then interest rate, the annual cost of borrowing money directly impacting total repayment. Okay, that's what we call it as interest rate. And then the present worth formula, the which is the mathematical tool used to discuss future cash flow back to the present day. Okay, that's what we call it as a present worth formula. Then the application in solar financing, crucial for assessing the viability and payback period of large scale solar project. Okay, that's what we call it as a application in solar finance. And the last one is loan tenure. Okay, the total duration over which the loan must be repaid in terms of years. Okay, this is the present worth calculation, the financial ecosystem. So here we know that the main objective is how can individual plan solar investment when payments are spread over a several years. Okay, so that's a very good thing which we have to concentrate. That means individual investment is worth more when we calculate it based on the years, because the money values will always be increasing, right? So this question requires us to bridge the gap between the today's cost and the long-term case commitment. Okay, ensuring affordable and budget-friendly for social adoption. Okay, so these are the things which we have already seen. So when it's come to the ideal state, so this is the overall visualizing the present worth formula, which is P is equal to A into, you can see the formula here. So this is the discount by investing rate. Okay, so by calculating the equal annual installment, let's apply the formula to a standard solar project loan, and then will the principal and the interest over the defined period. Okay, so when we evaluate, we have I rate which is 12 percentage. Okay, and when it's come to base rate, it's 10 percentage. When it's come to low rate, it's 8 percentage. Okay, so it is better to choose a shorter loan, which we call it as a minimum of 3 years with a higher EMI, or a longer loan, example 7 years with a low EMI. Okay, then the short term, we can categorize it into two: one is short term and longer term. When it comes to shorter time, less total investment paid but higher monthly stress, that we know that. When it's come to longer term, low monthly stress but high total interest we have to pay. Okay, so this is the present worth calculation of solar energy. Okay, thank you.